3,000 degrees and $3 worth of energy is all this laser needs to shoot down this drone, moving at 50 miles an hour. This is the Blue Halo Locust Laser weapon system. Under a dozen are currently deployed with the U.S. Army in classified overseas areas to take down unmanned aircraft. In Ukraine and the Red Sea, drones are changing warfare, making it easier to cause significant damage with cheap, low-tech weapons.
The future of proxy warfare is here, and that is a technological standoff between human life and technology.
Laser weapons are one of several relatively inexpensive responses to drone threats. But compared to traditional weapons, there are challenges. They have a shorter range and limited power, and can be harder to fix when something goes wrong. The Pentagon has not confirmed that a laser has successfully taken down a drone in combat. Here's how the laser works, why it may be the most cost-effective new way to fight drones, and why there are significant hurdles on the battlefield. The Locust Laser weapon system is a palletized high-energy laser, or PHEL, weighing in at 3,400 pounds and measuring 7 feet high by 7 feet long. The Locust can fit on the back of large Army vehicles like this Stryker. The weapon has two parts, the laser on the left and the tracking system on the right. The right houses an AI program that locks onto drones over 2 miles away, like this drone flying at over 45 miles an hour. The laser can take as many as 15 seconds to melt a target and can struggle to remain locked on it for long enough to take it down. Missile strikes, in comparison, are quicker, cause more damage, and can have a range 100 miles longer. The laser's software is designed to look like a video game, like Call of Duty, and it's operated with an Xbox controller. That's so soldiers who are familiar with the software can quickly learn how to use it.
When we can align how we actually operate the system with those natural skill sets, it's very powerful. But it's also, honestly, it's also just elegantly designed from a user interface and implementation standpoint.
But actually hitting the target in a combat situation isn't easy. The Locust's power source here transmits energy through these 12 cables.
Here you can see those individual fiber channels that all come together. Each one of those represents a little bit of a different spectrum of light, all coming together into the beam control unit here.
Without the beam control unit, the light particles, or photons, in the beam would be loose and disperse before they get to their target. In the desert outside of Socorro, New Mexico, Blue Halo demonstrated just how precise its laser could be. This white rectangle is an 18-wheeler truck about a half-mile away. In just 1.5 seconds of beam contact, it melted this 2-inch steel coin glued to the side. The $2,000 Mavic is traditionally destroyed with missiles costing anywhere from $100,000 to $3 million. Though the Locust varies in price from $8 million to $10 million, it can be used over and over.
A cost per shot of a Locust laser weapon is really $3. The ability to have essentially an infinite magazine at a very, very low cost of engagement at very, very effective ranges across a wide swath of threats. And that's a very powerful addition to the arsenal.
But missiles like the Patriot have ranges of over 120 miles, while the Locust can go just about 3 miles. And with just a few working lasers on the market, there are many logistical and technical challenges ahead. Laser weapons have intrigued the public since their invention in the 1960s, but the Defense Department started taking more interest in the 1980s.
I know this is a formidable technical task, one that may not be accomplished before the end of this century.
And experts still face some of the same challenges today. First, there's heat. As energy travels through the power source, then the spectrum transmitters, up the cable, and into the laser head. Some is lost along the way. Without air conditioners keeping the inside of the machine cold, it would melt the delicate tech inside the Locust. The second is weather. Photons in the beam will bounce off of particles in the air, like rain, sand from storms, or fog, dispersing the beam and making it less powerful.
No real difference than, in some degree, other weapon systems that can get impacted by sea salt or sand or humidity or any environment that they're operating in.
Both of these issues can lead to poor performance, like one February 2024 test of different lasers. Feedback from soldiers was not overwhelmingly positive, and they said that the lab and testing ranges were very different. When PHEL systems are deployed, there's another problem. Because laser weapons are so new, there is little infrastructure to maintain them. The Army has said it has been difficult to find spare parts and someone to fix lasers when they break in remote areas, for example, in African combat zones. Blue Halo says it aims to fix that issue by replacing specially made parts with mass-manufactured parts. For at least the next 4 years, Blue Halo will be providing on-the-ground engineering support for each deployed Locust. Other countries and companies are also developing lasers. The UK's Dragonfire had its first high-power firing against a target in March, with a cost under $14 a beam. Defense contractors like Raytheon and Northrop Grumman are also developing lasers for various tactical purposes, like this one that can fit in the bed of a pickup truck and this mini laser. Blue Halo, as well as other companies, plan on honing their designs so the lasers can be lighter, easier to maintain, and more effective. But concerns about these new weapons may continue until their long-term success is proven in combat.